Imagine a world shrouded in a bluish twilight, suspended more than 120 light-years from Earth, orbiting a cold, pale star in the constellation Leo. A planet that, in silence, hid itself for billions of years among the dense weave of deep space until human technology, armed with giant mirrors and sensors able to capture invisible light, revealed it. K218b. This is not just any planet. Astronomers call it a mini-Neptune, because its mass and radius are about 8 and 2 times those of Earth, respectively, but its true peculiarity is the secret it seems to hold in its atmosphere. A possible signature of life, a suspicious chemistry, an anomaly that has ignited hope and endless debate among scientists and the curious. The James Webb Space Telescope, with its infrared eyes, managed to decipher the encrypted messages of light filtering through the planet's thin atmosphere during its transits in front of its parent star. And that data, carried to Earth from millions of kilometers away, tells a disquieting story: the simultaneous presence of water vapor, methane, and carbon dioxide. Not only that, the detail that made many researchers jump is a possible signal of dimethyl sulfide, a molecule on Earth produced almost exclusively by living organisms, especially marine plankton. It is still far too early to speak of life, but the suspicion has been sown, and the scientific world is abuzz. K218b has, within a few months, become the symbol of a new era in the search for habitable worlds. Unlike other exoplanets, K218b is located in the so-called habitable zone of its star, that region where the temperature theoretically allows the presence of liquid water on the surface. But here things get complicated. The planet's size suggests it could be a world covered by a vast global ocean, protected by a thick, hydrogen-rich atmosphere. An environment radically different from Earth, and yet perhaps no less hospitable to the chemistry of life. James Webb's instruments detected an unusual chemical balance. The proportions of methane, carbon dioxide, and water vapor do not seem to be justified by simple geological or photochemical processes. On our planet, similar combinations are almost always the result of an active biosphere. And it is precisely this hypothesis that strikes a deep chord in human curiosity. What if, in that alien sea, there are colonies of microorganisms that breathe, feed, and leave their traces in the atmosphere? Scientists, cautiously, remind us that nature can be much more creative than human imagination. There may exist unknown, non-biological processes capable of producing the same molecules observed. But the temptation to believe that K218b is a living planet, at least at the microbiological level, is very strong. And every new piece of data collected only heightens the suspense. The atmosphere of K218b is a natural laboratory, rich in hydrogen, dense, protective. This type of environment could allow for very active organic chemistry, aided by the softer stellar radiation compared to our Sun. The presence of water, in the form of vapor and perhaps oceans, is the perfect catalyst. In laboratories on Earth, it has been seen how the combination of water, hydrogen, carbon, and energy sources can quickly generate complex molecules, perhaps even the precursors of life. The real puzzle is whether, on such a massive planet with such high atmospheric pressure, life can truly evolve. Perhaps the surface is inaccessible, crushed beneath kilometers of atmosphere, but in its upper oceans, where starlight penetrates and energy can fuel chemical reactions, there could exist worlds teeming with microscopic activity. Or life, if present, could be entirely different from what we know. Forms based on never-before-seen chemical cycles, exploiting the abundance of hydrogen for alien metabolic processes. The scenarios that open up are dizzying. Imagine organisms similar to those on Earth that live in the depths of the oceans, where light never reaches and temperatures are extreme. Creatures that do not need oxygen, but breathe hydrogen or methane, and can survive under terrifying pressures. Earth teaches us that life can adapt to the most hostile environments, from the hydrothermal vents of the Pacific, where chemosynthetic bacteria transform minerals into energy, to sulfur caves, to the icy deserts of Antarctica. Why couldn't the same happen on K218b? Meanwhile, the data collected is being analyzed for further clues. Scientists are searching for the presence of other complex molecules, like ammonia, which could indicate active biochemical cycles. They analyze the absorption profiles of light, seeking the faintest signals between the emissions of the star and the shadows of the planetary atmosphere. The challenge is enormous. At these distances, every piece of data is a treasure, every anomaly a potential signal to decipher. But there is another question shaking the research world. What if life on K218b were completely independent from ours, born from a different chemistry, in an environment that would be lethal on Earth? How would we recognize it? Perhaps we are already observing its signals, but are too tied to our biological preconceptions to interpret them. It's a lesson in cosmic humility. The universe may harbor forms of life we can't even imagine, based on chemical and biological logics that escape our categories. This thought leads to speculative and almost philosophical reflections. If life truly exists on K218b, it could be completely isolated, with no chance of communicating or leaving traces in space. We might be close to a groundbreaking discovery, yet condemned never to interact with those alien creatures, separated by insurmountable physical and chemical barriers. Or, one day, new technologies will allow us to capture clearer signals, to read the stories written in the atmospheres of exoplanets, to finally recognize a biological otherness in space. Awaiting definitive answers, the case of K218b has already revolutionized our perception of the cosmos. We are no longer alone in an inert universe, but explorers gazing out at a myriad of worlds where life may have taken infinite paths. Every new observation, every atmospheric spectrum, every piece of data collected by James Webb and future telescopes becomes an open window onto the unknown, a promise of new surprises. And while scientists continue to scan the data, to propose models, to argue over interpretations, one certainty is emerging. Our biological frame of reference is no longer sufficient to describe all the possibilities the universe offers. The search for life on K218b is not just a scientific matter, but a journey to the limits of our imagination. If the hypotheses about the presence of biogenic molecules should find further confirmation, our understanding of life in the universe would undergo a change comparable to the Copernican revolution. It would no longer be just a matter of supposing that habitable conditions exist in other star systems, but of admitting that life, at least in its simplest forms, can arise and persist in environments completely different from those on Earth. This would lead to a redefinition of the very concept of a habitable zone, no longer just a ring of temperature around a star, but a mosaic of possibilities, determined by the alchemy of atmosphere, pressure, composition, and chemical cycles, sometimes unimaginable based on our terrestrial experience. The scenario outlined for K218b is that of a natural laboratory, a unique testing ground for theories about the origin of life. If dimethyl sulfide or other similar molecules are indeed present in abundance in the atmosphere, it becomes legitimate to question which processes, biological or otherwise, might generate them. Some astrobiologists hypothesize the presence of ecosystems based on a chemical cycle profoundly different from Earth's, perhaps powered by the energy of the parent star through photosynthesis processes adapted to a hydrogen and methane-rich atmosphere. We could be facing an alien biosphere, where natural selection has produced organisms able to survive pressures and temperatures that on Earth would destroy any known cell. The presence of water vapor, detected with increasing precision by James Webb, makes the existence of an active hydrological cycle even more plausible. Evaporation, condensation, and perhaps constant rains feeding a global ocean beneath the atmosphere. In these marine environments, organic chemistry could have reached unimaginable levels of complexity, giving rise to real communities of microorganisms, perhaps even to multicellular forms of life, though still simple. Every element suggests a living, pulsating world beneath a blanket of clouds, waiting for human intelligence to discover its secrets. On a technical level, the challenge now is to further improve detection capabilities. James Webb represents a fundamental step forward, but new telescopes and instruments capable of analyzing exoplanet atmospheres in even greater detail are already being designed. The extremely large telescope under construction in Chile, for example, promises to scan the light of nearby stars with unprecedented precision, allowing even the faintest traces of biological or particular chemical gases to be detected. And in the next decade, missions like ESA's Ariel or NASA's Nancy Grace Roman Space Telescope should broaden our perspective on potentially habitable exoplanets, offering a wider and more diverse view of candidate worlds. Meanwhile, the emotional impact of this research is reflected in human culture and philosophy. The idea that life might be a widespread phenomenon in the universe shakes the foundations of our identity and our sense of uniqueness. Every new clue from K218b becomes a source of speculation, of dreams and fears, of reflections on the origins and destiny of life. The scientific community, while maintaining data rigor, thus finds itself having to answer existential questions. What would it mean for us to discover, beyond any reasonable doubt, that we are not alone? How would our position in the cosmos change if we had to accept that the universe teems with microbes, ecosystems, perhaps even civilizations still beyond the reach of our instruments? The scenarios multiply. On the one hand, the possibility of simple life, made up of microorganisms populating K218b's oceans. On the other, the temptation to imagine more advanced evolutions, worlds where natural selection has produced beings able to perceive, communicate, build. It is a vertigo that pushes science beyond the boundaries of biology, involving astronomers, chemists, philosophers, and even artists in the great adventure of knowledge. And meanwhile, every piece of data collected is a step forward toward the final goal: to distinguish, unambiguously, a biological signature from a geochemical phenomenon. It may take decades, perhaps the final verdict will never arrive, but the path taken has already transformed our vision of the universe. K218b, with its mysterious atmosphere, reminds us that reality is vaster than any fantasy, that the search for life is an unstoppable force, able to unite generations and different cultures in the pursuit of an ancient question: are we alone? The answer, whatever it may be, will have the power to redefine not only science, but the entire human adventure in space and time. If you have made it this far, it means you love curiosity as much as we do. If you enjoyed this journey, leave a like, write a comment, and subscribe to the channel. It's the best way to support what we do. Your presence really makes a difference. Until the next exploration.